Let's go see what's going on in the shop today. Morning. Cleaning your glasses?
Yeah, can't see out of them. They're all smudged with oil. I just finished putting the distributor together.
What's a distributor?
Distributes oil from one direction to another. You can bring in one and you can swivel it in the direction you need it.
So what is it used on?
Not sure the equipment they use it on. Just to localize in case they want to bring it into one side, bring it out the other, and then turn it towards the equipment it may be in. It had to be rechromed and had to be all cleaned out, retapped. It had to be outfitted with new O-rings.
Do we test this?
Yeah, Chris will test it when he gets in tomorrow, hopefully. So,
all right.
Yeah, it's pretty straightforward. Cool. So you can hold 1500 psi, and then be able to swivel it without it leaking at either end.
All right, cool.
Not that cool, but okay.
What are you doing?
I'm gonna take them apart, inspect them, see what quality they are.
What are these?
These are Premiers.
Okay. A P09?
Yeah.
Look at that cool thing. It's off a Caterpillar. A BMV. BMV 186.
The rod has to be chromed.
Oh, the one sitting out there.
Yeah.
We can go take a look. What am I looking for?
So here, this is acceptable, 2.748.
Okay.
This is not 2.747, and this is where most of the stroke is used, so it's worn. So my thought is this thing was sent out, and when it came back, it might not have been chromed up to this point.
That part's fine?
Yeah.
What is that? What's that part called? The barrel. The barrel?
The barrel, the tube, whatever
Don't
you
know.
want.
All right.
Seamless hone tube, and it'll be lightly honed and then remeasured.
Okay. Richard, good morning.
Hi, good morning.
What are you doing?
I was just testing a vane pump.
What kind of vane pump is it?
Wow.
T7E DS. I can
There
read
you
it.
go. A tandem.
It's a tandem?
Wow, there's one suction and then two, a P1 and a P2.
Interesting. Oh yeah, the cartridges.
We have 52 GPMs and 31 GPMs.
And what do you have to connect to?
Oh, I already did,
Oh, you
but
already tested it.
yep, I already tested them. But,
All as well?
The two flow meters, yeah, all as well.
Nice.
Sorry, I don't have a large sight.
That's okay. What are you guys doing? PvP?
23. There's an issue with the comp, but we got it.
What kind of comp is it?
Load sense.
Tell me about a load sense comp.
It just senses the load coming in and adjusts the output flow.
Tell me about a pressure compensated control.
Goes up to a preset maximum pressure and just compensates the pump. Basically puts out just enough flow to maintain pressure.
And never goes over the set amount.
Yeah.
What do you guys look for on this chart?
Mostly you're looking at pump flow and at the case flow.
Okay.
If you have a lot of case flow, it means that your internals just aren't mating properly. You have too much case leakage. And that can also show through just not enough actual pump flow.
And is a little bit of case leakage normal?
You have to have case leakage.
Okay.
If you didn't have any case leakage, basically you just have two metal surfaces against each other just grinding away.
Gotcha.
It's the oil film between it that has to squirt out to provide the film. That's what basically keeps it running.
Gotcha. Hey, how are you? Oh, this is what you want?
What?
You want to buy that?
Well, Trent wants to buy it and,
For you?
steal my sockets, yeah.
Damien really needs this. Anyways, what are you doing?
I'm building 4 more of those.
Oh, I was going to say, this looks familiar.
Yeah, 4 more of the custom.
Okay, that's just because we
machining.
had the parts.
Well, no, there's another order of 6.
I hope to never look at one of these again.
You know what? Apparently they're not very common, so
For
it's
us,
weird.
they are.
Yeah, we've had 3 orders of them in the last bit, so.
All right, maybe that's what we're known for now. What are these little thingies?
Those are spools. I was searching for a specific spool for another job, but if you look here, it's actually pretty interesting. It gives you all the different kinds of spools. So I was searching for a number 4. So basically,
Does it just say right on there, number 4?
No. So you have to go by the design. See how you can see they have little differences.
Yes.
So you have to kind of like match it
Jeez,
up.
so I can pick one of these and try to match it up?
Possibly.
This is 11. No, it's not. It said 11 on it.
Yeah, so that could be for a different valve.
Okay.
So that's why it's a little tricky.
Okay.
Yeah.
I don't think this
I
one's
didn't
on.
find. I couldn't find the right one. We don't
Yeah,
have
this
it.
one's not on here. You couldn't find the one you needed?
No, we don't have it.
This one I can't find on there at all.
That would take all day to count all of those.
Yeah. Let's try this one. It's a 1.
It's got 4.
No, but then it's not a 1. No, it's not a 1. I hate these numbers. They're lying to us.
Yeah, like I said, so there's like different types of valves, right? And
Okay. They need like Google Lens for this.
Yes.
yeah.
Okay.
A little tricky.
Fun. All the time. I really just want to know, did you score a goal in hockey on the weekend?
Yes.
How many?
1.
Was it a good one?
Yes.
That's all that matters. Okay. Good. What are you doing?
Oh, I'm just I'm making some control for Premier pumps. Premier is an open loop pump that is no longer being really manufactured, so these things are very rare, and I'm taking components. I just finished this one this morning. It's a compensator control, C1 control for Premier pumps, where it's all the way from 9 to 16 cubic inch pump. This is called a buck-up cap for a Premier. So never judge a book by its covers. Look how awful this looks, right? Like it's dirty. It's a lot of the paint and grease has actually adhered because of heat. This is what this looked like before I worked on it.
What do you have to use?
Well, I use paint strippers, which this is. See, I'm working on here.
Oh yeah.
This was all blue before.
Oh wow.
You can see.
They don't really make these anymore. So they're very rare. That's why they're very expensive.
Do we know why they don't make them? They just didn't sell a lot of them, or?
Well, Parker went, this is originally from Denison.
Yeah.
And Denison was bought out by Parker. And Parker has their own line of open loop pumps, and they want to probably not have, I'm only guessing now, as many different open loops, so they try to make not so many models.
Makes sense.
So what they went to is, I think, a P2 or even a PV plus. So
And how is these going to potentially go on the units that Trent is about to work on?
yeah, they're very similar. That's what this is, and this is what I just finished working also
Okay.
over there. So what this is it has a spring in there and a pin, and what it does is the air, hydraulic pressure and a spring will try to push that onto when it comes off stroke onto full displacement. Like it pushes the swash angle over, the pump is on full stroke or whatever stroke they want it to. This is called a max volume cap, and it also is, this is where the compensator is. In here, we set the compensator to a certain height, so at that certain pressure, it goes to 0 displacement. So it won't pump any oil anymore. It doesn't ruin the pump, depending what it's set to.
Is that kind of like a pressure compensator control?
That's exactly it.
Oh, okay.
And that's an open loop pump, meaning oil goes into here and comes out of here.
Can you explain a little bit about like the pressure compensated controls?
Gold cups are also pressure compensated mostly. You have this cone, you see that, and that's a seat in there. This is a cone which sits in there on a spring. This is just a spring retainer. Certain customers want the pump to de-stroke at a certain pressure. That's what a pressure compensator does. So the more I turn this in, the higher the pressure will go to go to neutral. If I back it out, obviously it will compensate earlier.
So to be able to, like, let's say you wanted to set it like 3,000 PSI or something, do you have to do that on the test bench kind of thing?
Yes.
Okay, so
That's
if
the-
it's set at like 3,000 PSI, let's say,
Sure.
essentially it will not go higher than the 3,000.
That's correct. And there's a formula for it. Cubic inches times rotation divided by 231 will give you what flow the pump will produce.
That.
This is the safeguard so the pump doesn't blow up.
And you need
And this pump is rated to approximately 5,000 PSI.
this one in particular, yeah, okay. Oh, this was really helpful.
I hope it was.
I've been trying to learn about pressure compensated controls.
But this is the simplest control there is. So this is the most common one.
Do you want to give your grandson a shout out?
Yeah,
Oh,
say
my
hi.
son?
Yeah.
No.
Say hi to his class.
Yeah, they'll appreciate it.
Literally. Say hi to everyone.
Hi, everyone. Hi, Mr. Nickel.
Hey, Lloyd. Smile. I want to ask you a couple questions. They're true and false.
Actually, you know what? Let
Bell's
me
gonna
ask
ask.
you guys.
Sure.
True or false? In a fixed displacement pump, the pump is always at full flow.
No. No.
False?
No, it's true. It's running, yeah.
What if the pressure gets too high?
Then the relief valve will go off, but the pump's still pumping. Because it's a fixed pump, it has nowhere for it to go, so it has to stay stationary. It's like a gear pump, basically.
Okay, true or false? In a variable displacement pump, the flow and pressure can be charged.
Changed. She can't read.
True.
Sorry.
In a variable displacement, it can be changed. Yeah, absolutely, it can be changed. But does it need a control to be changed?
Well, if you're having a variable pump, generally it does have a control.
Okay.
You got to have some. You can have a min or max volume adjustment screw to change your flows, but there's got to be some kind of compensator on it.
Okay. Next.
Okay, and last one. True or false? There is less heat generation in a variable displacement when compared to the fixed displacement.
I know the answer to this one.
Now that's a trick question,
Why?
really, because if you're running a fixed pump in a circuit that is running at 1,000 psi that never goes over relief, if it's properly sized, you should never have a heat issue.
Okay.
If you're running a fixed pump that's running up to 5 grand, it's dumping over relief all the time, it's going to create a lot of heat. Or a variable pump, if you have a load sense, it's going to do the supply and demand. So it'll all depend on the system and the application.
I promise to not bother you for the rest of the day. Do you want to talk about your most hated tool today, or do you want to do it tomorrow?